All right, so far in this unit, we've talked about the basic structures of geometry of points, lines, and planes, line segments, rays. We've talked about how to find the length of a segment and the middle of the segment with the distance formula and the midpoint formula. And now we're going to talk about another basic structure, the angle. What are angles? And how do I use them? Angles are going to come up over and over and over again throughout geometry. There's a number of different names and relationships when we start talking about two or more angles. And it's real important to actually learn all of these definitions. All right, so this first example here is angle ABC, and this is an example of an acute angle. Okay. And I guess I'm going to take off the word acute and just say angle. I think this is generally just the definition of the angle itself. An angle is formed by two rays with a common endpoint. Okay, the endpoint, looking at this example, is right here. That is called the vertex. The rays, which in this example are here and here, these are called the sides. We name an angle using three capital letters. The middle letter must be the vertex. Okay, so if I was naming this example here, I would say angle, which looks like the less than symbol with an arc through it, A, B, C. Or I could say angle C, B, A. Okay, the vertex is in the middle, B is in the middle. This first one is our preferred option because A and C are in alphabetical order. All right. But both are correct. You can use a single letter to name an angle only if there is no other angle located at the vertex. So in this example, I could say angle B. That's the only angle here in this particular picture. But if I had this diagram, let's say A, B, C, I could not name this angle B because I could be talking about angle ABD, or I could be talking about angle CBD. Okay, so there has to be no confusion if you only use a single letter. To be safe, always use three. Okay, and then nobody can be confused about what you're talking about. When we refer to the measure of an angle, when we refer to how many degrees it is, we use a lowercase m in front of the name. So for example, the measure of angle ABC in my example over here equals 60 degrees. Okay, so types of angles. There are three basic types. Okay, and we're talking just a single angle all by itself. Okay, let's see, acute angles measure between 0 degrees and 90 degrees. So for example, we could say that this angle measures 45 degrees, and let's label it C, D, E. Okay. We could also have F, G, H, and this could be 89 degrees. Okay, so acute. Cute animals are generally small, cute little babies. So small angles, acute, that's one way to remember it. Obtuse angles measure between 90 degrees and 180 degrees. So let's see. M, N, P, and this could be 170 degrees. Or I could have, let's see, that was an acute. I don't want that. I want just a little bigger. I could do 120 degrees for X, Y, Z. Oh dear, looks like I made a mistake earlier. I guess we're doing the 5 basics. So let me go back. Sorry about that. 3 basic is actually what you learn in elementary school and here in the United States. And then 5 basic we pick up in high school, and I just wasn't thinking. My apologies. A right angle measures exactly 90 degrees. So we have a symbol for right angles. We draw in a little baby square at the vertex, and that tells whoever's looking at this that this is a right angle. Oh, let's see. H, I, J. A straight angle measures exactly 180 degrees. A straight angle and a line are the same, in appearance at least. A, B, C. We often do this to let people know we're talking about an angle and not a line. And then the last kind is called a reflex angle. Now this has to measure between 180 degrees and 360 degrees. 360 degrees is a complete circle. Okay, so let's look at what a reflex angle would look like. A, B, C. Now if I leave this drawing the way it is, that is an acute angle. If I want someone to look at the reflex, I am going around the outside, and I have to draw this part of a circle around the outside of the vertex to let them know that's what I'm talking about. So let's look at what it looks like with an obtuse. A, B, C. Okay, that's an obtuse angle, but I want the reflex. So I'm going around the outside, which means I draw part of a circle from side to side around the outside, letting someone know you're measuring more than 180 degrees. Okay, so how about some practice here, naming parts of an angle. The vertex is the common end point. My vertex is K. The sides are rays. So K, J with the ray symbol because it's a ray, and K, L with the ray symbol because it's a ray. Remember, rays have to start with the endpoint and then go on forever in one direction. So let's name this angle 3 different ways. The best way, angle symbol, would be to put K in the middle and put J and L around it alphabetically. So J, K, L. The second best way would be to put K in the middle and L and J around it, not in alphabetical order. And the least best way would just be to say angle K. All right, in this particular picture, we have to be talking about angle JKL. But if I added another ray in there somewhere, then it's not clear what angle K means. If you always get in the habit of using 3 letters, then you don't have to worry about losing points for not being clear. So classify the angle. Is it acute, obtuse, right, straight, or reflex? Well, it's not acute. It's definitely more than 90 degrees. It's not right. One of the things you can do is you can use what we call the corner test. You can line up the corner of your paper on the vertex and the top edge of your paper here along KL. And when you do that, you will see that you are bigger than, I'm going to sketch a fake piece of paper here. When you do that, the corner test, the corner line up around KL. Okay, you can see we're bigger than 90 degrees. The corner of your paper is 90 degrees. So this is greater than 90 degrees, but it's not a straight angle. It's not a line. So that makes this obtuse. Okay, I really like the corner test to help me figure things out when I don't have a protractor handy. All righty, name the vertex of angle 2. Now, we've got a lot of angles going on here. All right, so to help us clarify, they have numbered the angles. This is angle 2. Okay, and my vertex is point T. Name the sides of angle 5. Well, here's angle 5. Angle 5 is a right angle. I can tell by the marking. And the sides would be ray TY and ray TW. What is another name for angle 4? All righty, here's angle 4. Okay, angle 4, the vertex T has to be in the middle, W and Z on either side, and I put those in alphabetical order. What is another name for angle WTZ? Well, they labeled that angle 4, or I could say angle ZTW. What I could not say is angle T, because there's 5 different angles going on there around the vertex T. And if you just say angle T, I have no idea which one you're talking about. So that would be a very bad choice. All right, I'm going to get my little fake piece of paper here to use to help me classify these angles. XTU. All right, XTU. So, don't do that. I'm going to turn it. Okay, XTU is clearly smaller than 90 degrees, so that makes it acute. YTW. Let's see. I'm going to erase all these colors to help myself out here. YTW. Oh, that's marked with the right angle symbol, so that's really nice. Right. YTU. YTU. Okay, not sure if that's a right or an obtuse. So here I come back with my paper test. Come on. Bigger than a right angle, which makes it obtuse. And WTX. Oh, that's a straight line. So it's straight. Okay, often drawing on your diagram is super, super helpful. So this allows you to do the basic angle classifications and naming. Please take a few minutes to write guiding questions and a summary.